Today, we are cracking a code. But this isn't some modern encryption. It's an ancient secret. And believe it or not, it's hiding right inside the most advanced technology we have. So, let's just jump right in. What on earth could modern AI possibly have in common with math from the 9th century? I mean, it sounds kind of crazy, right? But the answer, well, it connects our world to the distant past in a way you probably never expected.
And we're not talking about some vague philosophical influence here. No. This is a precise blueprint, a 1,200-year-old secret that literally forms the foundation of how AI thinks today.
So to really get this, we've got to take a trip back in time. And I mean way back. We need to meet the person who kicked this whole thing off. So meet Muhammad ibn Musa al-Khwarizmi. He was a Persian mathematician back in the 9th century, and he came up with an idea that was, well, it was completely revolutionary. He basically said that any calculation, I don't care how complicated it is, can be broken down into just 3 basic parts. And this idea, it was so powerful, it's where we get the word algebra from. Okay, so what are these 3 magical building blocks? Let's take a look. And you're going to be surprised, I think, at just how simple they really are.
All right, first up, we have what he called the root. It's just the thing you don't know, right? The unknown quantity you're trying to figure out. He called it the root because the square, and we'll get to that in a sec, grows right out of it. Today, you and I know it as, well, just x.
And next, you guessed it, we have the square. And it's exactly what you think it is. Just the root, multiplied by itself. So if your root, your x, is 5, then the square is 25. Super simple, right? And of course, today we call this x squared. And the last piece of this puzzle is the simple number. This is just a normal, constant value. It's a fixed amount that doesn't change no matter what the root turns out to be. It's kind of like the anchor in the equation, something solid and predictable. And for us, that's just c.
So, let's just put it all together. You've got his root, which is our x, the big unknown. You've got his square, which is our x squared. And you've got his simple number, our constant c. That's it. That is the entire toolkit he used to solve everything.
Okay, so we've got our 3 pieces, the root, the square, the number. But how do you actually do anything with them? Well, the whole thing hinges on one really elegant, really powerful idea, balance. See, the real genius here, the big aha moment, was realizing you could make these things equal to each other. You can put them on either side of an invisible scale. You could say this many squares is equal to this many roots. And just by doing that, poof, you've created an equation. You've created a puzzle that you can now solve.
And get this, he didn't use all our modern symbols. He didn't write x squared equals 5x. He just said it. He wrote it out in plain language, just like this, square equals 5 roots. It's so clean, so direct.
And solving it is surprisingly straightforward. You start with the statement, right? X squared equals 5x. Then you just do a little shuffling, you rearrange it, you pull out the common factor, the root x, and suddenly the answer just pops out at you. The root x has to be 5. And just like that, the puzzle's solved.
Now, what's so important to understand is that this isn't just a neat little party trick for one specific problem. No way. This simple idea of balancing roots, squares, and numbers is the engine. It's the core principle that drives every single quadratic equation. It's a fundamental pillar of math.
Okay, we've laid all the groundwork from the ancient world. Now, let's do the fun part. Let's leap forward in time and see how this connects to the AI you and I use every single day. All right, brace yourselves, because we're going to fast forward 1,200 years in the blink of an eye, because that exact structure we've been talking about, the root, the square, the number, that is the secret code humming away inside modern artificial intelligence. Okay, this is it. This is the big reveal. Al-Khwarizmi's root, that unknown x, in AI, that's called a feature. Think of it like a variable input, someone's age, the temperature outside, the price of a product. Now, what about the square? Remember how it relates the root to itself? In AI, that's called an interaction. It measures how different features play off of each other. And finally, that humble, simple number, the constant, that's what AI calls a bias. It's a fixed value used to nudge the final result. It is literally the exact same blueprint, just with different names. So this isn't just some cool piece of trivia, right? This connection shows us something really, really deep about how we as humans figure things out. Just think about this idea for a second. Algebra begins when we treat the unknown like a number. That was the giant leap forward. Instead of seeing the unknown as a scary, unsolvable mystery, Al-Khwarizmi gave it a name. He called it the root. And by doing that, he turned it from an obstacle into a tool. And that is exactly what AI does. The whole field of AI begins when we take massive, messy, complex data and we treat it like it's just a bunch of variables in one enormous equation. The goal hasn't changed in 1,200 years. It's all about finding the perfect balance between all the different pieces to get to the truth.
So next time you ask an AI a question, just for a second, remember there's kind of the ghost of a 9th century mathematician in there, still balancing roots and squares. It really makes you wonder, doesn't it? What other ancient secrets are hiding all around us, quietly powering the world we live in today?